All right, hello everyone. Can you guys hear me clearly?
Yes.
Okay, thank you. All right, Aggie, are you there?
Yes, I'm here.
Okay, so shall we start?
Yeah, thank you.
Okay. Once. All right. Greetings, everyone, and welcome to our highly anticipated webinar entitled Road Safety Audit Practice in Sarawak. And also, I hope it's not too late for me to wish you a happy new year. On behalf of PCSS, we are excited to have all of you today with us as we dive into today's topic. My name is Angelina, and I will be your host for this afternoon session. Before we begin, let's go over a few housekeeping details to ensure a smooth and engaging webinar experience for everyone. First and foremost, please be informed that this webinar will be recorded for future viewing and to distribute to those who are unable to attend today. Secondly, we would like to request that all participants to keep their microphones muted throughout the webinar. This will help to minimize any background noises and ensure everyone can hear our speaker clearly. And please feel free to drop your questions along the way in the chat box throughout the session. We will do our best to address them. And thirdly, attendance will only be shared through QR code at the end of the session, together with the feedback forms. So do stay with us until the end of the session so that you can scan the QR code. Before we begin, let me do a quick introduction of PCSS Consultancy. So PCSS is a project management solutions provider focused on enhancing organizational profits through the implementation of industry-leading practices. We specialize in digital construction, covering in BIM, 4D simulations, optimizations of tools such as drones, AR, VR, to name a few. This emphasizes our dedication to staying technologically advanced and providing innovative solutions for the digital transformation of the construction industry in the region. Right. Now, ladies and gentlemen, our speaker today, let us welcome engineer technologist Dr. Agilarajan. So let me introduce him to you a little bit. So he is an experienced civil engineer with over a decade of involvement in the civil engineering, road safety audits, and project management. He has contributed to successful delivery of impactful infrastructure projects, working closely with multidisciplinary teams and stakeholders to support practical, sustainable, and community-focused solutions. His work in road safety audits emphasizes compliance, resilience, and real-world application. Beyond the industry practice, he is actively engaged in academia as guest lecturer and mentor, focusing on bridging industry experience with education to prepare future engineers with relevant and practical insights. Without further ado, let me hand over the session to Aggie whenever you're ready.
Okay. Good afternoon, everyone. Thank you, Angeline.
Good
Okay,
afternoon.
now I will share my slides.
Yeah, just share away.
Okay. Is the slide? Can you see the slide?
Yes.
1 minute. Let me get rid of this. Okay. Okay. Good afternoon, everyone. My name is Agilarajan. Can call me Agi. Today we will just go through about the road safety audit practice in Sarawak. So first of all, what is it all about? What is road safety all about? Okay. First of all is It's a formal examination of the planning, design and construction of a road project. It is and the characteristic and operation of an existing road. This is done by an independent and qualified examiner. Okay, to identify any potential unsafe features of operation arrangement that may adversely affect the safety of any road user. So this is one of the main book we refer. So this is the Road Safety Audit Guideline for Safety Audit of Roads and Road Projects in Malaysia. So this is the thing. And then why do we do it? So when we talk about road safety, I would like to answer this question: what, why, who, when, where, and how. So the next one will go into why. Okay, why? First of all, why do we do road safety audit? Because road safety audit, we can first of all detect and eliminate unsafe features on the road. So, because road safety audit starts during the conceptual design stage of a project, where it is before construction, before the detailed design is carried out. So, stage where the changes to design is easily made and avoiding costly redesign, reconstruction. And also during the design stage, you can actually pinpoint the issues and start looking for mitigation. Okay. Next, it also helps us to identify and eliminate inappropriate, out of date standards and practices. There are some things that some people tend to forget. There are some types of guardrails cannot be used anymore for the moment. There are types of guardrail in treatments. So sometimes it is overlooked. So we want to find out all these unsafe practices and eliminate it so we can have a better and safer road. Okay, now why we do it? Very simple. When we reduce the likelihood of crashes, it will be better and safer road. Then when sometimes we can also help to reduce the severity of crashes and reduce the remedial the cost of remedial works, and also when we reduce the cost and we also can save people and save time and include the road safety, increase the road safety prominence. Okay, so this is the why. Next, we'll go to who. So normally, road safety auditors are normally independent personnel, and then they are accredited, and then their skills should include road safety engineering, traffic engineering, traffic management, road design, accident investigation, and countermeasure. And they should be able to foresee potential safety problems from the viewpoint of various road users. Okay, this is an outdated list, but this is one of the list of people. These are the list of people who are practicing road safety auditors in Malaysia. So these are the people here. This is the list. This is I think this is a superseded list, but yet it is still most of them are still there. Maybe there is some more little bit more additions. Okay, next. After who, then we go into when. Okay, as I said, road safety audit, we can break it into two stages, two main stages. That will be during the design stage. Design stage will be we can go into deep into the stage one, two, and three. Where stage one is normally focused on feasibility and planning stages, and where the consultant normally submit their conceptual report for the auditor's review. Next, stage two. Then that is when it is the PED, the road safety auditor reviews the PED, preliminary engineering design drawings of the consultant, and then continued by stage three. Stage three is done based on the DED, detailed engineering design drawings by the consultant. This is the design stage. Then after this, normally we will have, before it goes to the construction stage, there is one stage within the RSA stage three, that will be the compliance, RSA stage three compliance. Whatever, after each stage, normally we will have a decision meeting where consultant will submit the drawing, the auditor will come up with their comment, and the consultant can respond to the comment whether is there any changes, or they are going to put in any rectification work, mitigations, or they're going to revise the drawing and everything. And those things which is not agreed, I mean, there are disputes or there are they don't concur with each other, the auditor and the consultant, they can bring it to the client. Then client will put in give in their decision. So after each stage will have a decision meeting. So stage three, after that they will have a decision meeting. And after the decision meeting, then you can have then the new drawings will be submitted to the auditor for a review, and that will be addressed as RSA Stage 3 compliance. So in that compliance report, you can go through, when you go through the compliance report, whatever has been decided during the decision meeting, they have to just check is it complied or not, because the next stage after that will be construction stage. Construction stage will be, there will be stage 4 and stage 5. But this stage 4 is divided into three parts. First stage is TMP, Traffic Management Plan, where the contractor will submit the traffic management plan, and also the consultant will submit their construction drawing to be reviewed by the auditor. Then part two. Part two is during construction. Normally, it's about 50% of completion of the project, where the auditor will go to site and actually review what is happening, and they will come up with a report. And finally, for stage 4, before the road is open to public, the part three, RSC stage 4 part three will be done. Okay, so once all this thing done, then we go to stage 5. Stage 5 is after construction during operational stage of the project. So normally it can be done within 3 to 6 months after the road is open. This is more on to check, it's more on forensic type of thing where you go and check on what is actually happening. What happened? You can see this is where the auditor will go and review and audit whether is there any skid marks or any guardrails. I mean, you can see normally roadside they have guardrail, right? So those guardrails are any of the guardrails are affected or things like that. Okay. So next we'll move on to after when is where. Okay. Stage 1 normally is done a desktop study whereby the consultant will submit the conceptual report and we will do the desktop study. And in order to actually appreciate the site and to know what is it all about, we will actually have to conduct a site visit as well then. Then stage 2 is because of the PED drawing is done as a desktop study. Stage 3 also is desktop study. Now, stage 4 is construction. Normally, we will have desktop study and site visit because we need to go to the site to audit the site. Okay. Similarly, stage 5. So this is the where, and then we are moving to how. This is the main chunk of the topic today. Now, there is, as I told you, there are stages, stage 1 to stage 5. We'll go into stage 1. For stage 1, first of all, we check the traffic planning strategy. So what do we check? How it impacts the existing road network. Okay, when you want to introduce a new project or anything, you need to see how it's going to affect the existing traffic network. Then how is the implication of your new project implications to the existing road safety, and how is it going to serve the whole population there? Next, next we are going to route standard. Okay, normally route standards are, okay, you can see this. This is from ATG 8-86 Pindaan 2015, 2015. So we have types of, this is a hierarchy of road. You have rural, there are two types of road. One is two major distinct. One is rural, one is urban. So for rural, we have from R1 to R6. R1 is the lowest standard, meanwhile R6 is the highest. Okay, so R1 and R2 are normally classified as minor roads. R3 and R4 are considered secondary road. R4 and R5 are primary, and R5 is highway, and R6 is expressway. Okay, now Pen Borneo Highway is R5 road. So that's an example of it. And R1 roads, you can see a lot of Ricotta projects. There are a lot of Ricotta projects done in deep areas. Those are R1. And R3 roads are normally the roads where very simple distinction, you can see the lane width. if your lane width is 3.25 meter per lane, it's normally R3. Okay. Similarly, urban roads. Similarly, is the lowest is U1, the highest is U6, and U1 is normally local street. Local street can be between U1 to U4, and similarly, collector can be U3 to U5. Arterial can be U4 to U5, and expressway is U6. Okay, this is these standards are normally chosen. One of the ways to choose these are based on um the ADT, annual daily traffic. Okay, next is next you can see this is the speed of the road. So how to see the speed? Basically, just now we discussed about R1 to R6, U1 to U6. Now, for rural roads, we normally look into the terrains, either flat, rolling, or mountainous. So the speed for flat is higher, rolling is in between mountainous and flat, and mountainous will be slightly lower. But for urban roads, it's normally they don't you don't see the terrain. You look into the area type 1, 2, and 3. One is relatively clear. I mean, when you have a road, you don't have any sensitive area. You don't have many buildings there, many utilities there. Those are type 1. Meanwhile, when you see the area is areas where you have a lot of sensitive buildings such as hospitals, schools, churches, mosques, temples, things like that, those are a little bit more trickier to handle. That and also you have to check the utilities and everything. So those will be R3 and R2 will be something in between. Okay, so moving forward, now we'll go into road network effect. Okay, road network effect, implication to existing accesses. Now, when you want to do some any widening or upgrading of any road, so normally from a single carriageway, you want to make a dual carriageway. What will happen is now you are going to introduce a median where people before this they can turn left and turn right from any accesses. Now they cannot do that. How they're going to do? How they're going to turn and make a U-turn after this? Then you have to introduce, like in Sarawak, we always use P-turns and things like that, indirect U-turns. So depending on the road standards, we can implement either direct U-turns or indirect U-turns. So hierarchy of connecting road. So for instance, you have a R3 road. What is the normal road which is connecting to the R3 road? Normally, you can connect it to R1, R2, and sometimes if you want to connect it to if you want to connect it to a bigger channel, bigger road, so R3 can be connected to R5 as well. So those are the things. Next, you have to check on the junction capacity. Junction capacity is very important, whereby you don't want a car to backlog, creating a big issues. If you can see nowadays, many excesses have been created after roads are done. So this excess sometimes, for instance, we can see in nowadays those people who are passing by like Emat Batukawa here. So I've noticed they've changed the access and things like the access. So now what happens here? This particular access change is actually backlogging the traffic into the Jalan Batukawa Matang there until it is creating such a jam over there. So this is an example of it. Then numbers of direct accesses. So you have, okay, now, normally there is something called access control in determining road standard. So normally for R1 type of roads, you don't have any access control because it is serving to houses and everything. So you can have as many access as you can. But there are something for R3 and above, normally you'll have partial access control where from one access to another access, you need some space, and you can actually check it in the 11 stroke 87, ATD 11 stroke 87. It is stated clearly there. So, and then if you want to go to even higher standard for R5, R6 road, then the access is even more, the space between each access will be more. So that things we have to take into consideration. Then acceleration, deceleration lane. As I said, the hierarchy of the road connecting. From R3, the speed of R3, assuming you're taking a speed of 50, connecting to a speed of 80, 80 or 90. So now, from the 50 kph, in order for your car to go to 90 kph, you need the car to from driving into a faster lane. You need a special lane called acceleration lane for this car to actually accelerate to reach the 80 kph. So it will have a seamless connection and to reduce the potential conflicts between these vehicles, because you want to make sure all the vehicle travels in a more uniform speed. Similarly, it also happens for the deceleration lane. Deceleration lane also from a very fast road, you want to go to a small junction, right? So when you want to go into a junction, what you need to do is you have to slow down. But if you slow down on the main line itself, that will be another potential problem. So because you cannot suddenly hit your brake to reduce the speed instantly. So what you do is you have a deceleration lane. When you have a deceleration lane, cars can go slowly. You can go into that lane to reduce your speed to enter into the particular lane, okay, into the particular access. Next, general geometry standard. Okay, basically, we are using for geometry standards, we use ATG 8/86 Pindahan 2015, 2015. So this is a guide on geometry design of roads. Next, we will use in Sarawak, we normally use the ATG ATG 11/87 Pindahan 2017, a guide to design of at-grade intersection. And for rural low volume roads, only in Sarawak we normally use this guideline for the design of low volume rural road LVRR. So this is introduced in 2015 as well. So this is one of the special thing we use in Sarawak, especially for rural roads which has low volume, like in Long Tujang and Long Miri and places deep areas like that. We tend to utilize this standard where it allows much relaxed in terms of the requirements, in terms of lane width, in terms of the gradient, and things like that. Okay, so moving forward. Oh, okay. And also, normally there are other manuals we can use. RIM guideline, GL1 stroke 2000, I think. And then also, you can use ASHTO, you can use Malaysia Highway Authority, MHA, LLM guidelines as well. But normally, for the for the roads in Sarawak, we use this. Moving forward, outline special provision for users with special needs. Okay, now normally when we say special needs, it's actually VRU. We call it vulnerable road user. Pedestrian are vulnerable. So normally we have to check on the walkways. How is the walkways? If it is on a bridge, the footpath, is it raised or not raised? What type of barriers you have? Like even if you put a curb, you have to check the type of curbs. And also, like if it is a long road, sorry, long, like it's a wide road. So you have to have a pedestrian refuge in the center. So we have to take into the consideration. Next, motorcycle lane. So motorcycle lane, if you're providing motorcycle lane, you have to know how much the proper width is provided or not. Is it comfortable for the motorcyclist and everything? And if there is a need of a separation, is it properly given? And then next is bicycle lane. So these are the types of special needs thing, and also other things are in certain highways, they do produce a refuge for motorcyclists during rain, so they can stop temporarily from moving. So those are also considered. Next is Um, for stage one, we also review the alternative alignment. Normally, if you want to for during this in conceptual design, the consultant normally provide more than one type one alignment options. So we will actually study all the options given, and then also for provision for public transportation, where the bus stops and everything is provided or not. Okay, moving forward to RSA stage two. Now, RSA stage two, you will go through the design criteria, typical cross section, horizontal vertical alignment of the road, intersections, climbing lane and overtaking lane, traffic sign, road marking and road furniture, then finally the TMP. Now, let's just go to the design criteria first. Okay, now just now I think we have covered the table just now a bit, but when I spoke about the terrain just now, right? There are a few the three types of terrain I mentioned just now: flat, rolling, and mountainous. Normally, flat terrain. How do we know about this? Now, normally we can get this information from the survey information, so the ground survey information. Normally, if your cross slope is below 3%, you can consider that as flat terrain. And for rolling terrain is 3 to 25%, between 3 to 25, and whatever more than 25% is mountainous. Okay, so sorry. And then next, we will go to the typical cross section. So this is an example of a typical cross section of a R3 road. And you can see the lane. What we do is by using the ATJ stroke ATC Pindaan 2015, it is all this width and everything is stated there. So we will check one by one. So if a R3 road, the lane width is 3.25 meter, so they have provided correctly. And then you have to check the shoulder width. According to ATG 886, the shoulder width for R3 is 2.5 meter, usable shoulder. Usable shoulder is inclusive of paved shoulder, and a paved shoulder of 1.5 meter must be provided. So according to the standard. So this is an example of it, and this is how we normally check. We will go through each drawing and we will comment on each drawing. So, and we'll move forward to the next one will be the horizontal and vertical design. Okay, now, normally for horizontal design, it's very simple. Horizontal design is like a bird eye view of the whole thing. So what you can see is a plan view. Normally for alignment, you can see that how we'll do is we'll do a tangent, and fit in a curve between. This is a I'm simplifying a very big process, sorry, yeah. So now you put it, so you have a tangent, and then you fit in a curve. So that curve, the radius, you have to determine the radius, and then you have to determine the transition length and everything from the tangent to curve. And those things you can obtain it from ATD 86 in 2015. Now, what another thing you have to look into in obtaining this is by the checking the super elevation. Super elevation is the curve is um when you want to turn left, the roads are normally not straight, it's not flat. It's normally it has a camber. So normally you have at straight section you have a 2.5 percent and 2.5% camber. Why? One of the main reason is for water to go out of the pavement. So we don't want any water ponding there. We don't want any aquaplaning. So when water ponding happens, then aquaplaning can happen, and it is unsafe for the road user. So normally you have 2.5% like this. So now, so when you have turning from the 2.5%, it will go to a super elevated. So the car will be one car will be going here, one car will be going this side. So you can see the super elevation there. This can be clearly seen in velodromes. For when you see the bicycle racing, you can see where the place they turn it is slightly others they have a proper super elevation that is very clearly you can see there. So similarly, um, for the super elevation, normally for urban we will use 6%. For rural, we use 10% according to ATJ lah, Arahan Teknik Jalan. So we use that. So for this, for rural road, if you're using 10%, assuming, let's just assume your road is 50 kph now, and you want to fit in a curve of 130. So you can see your super elevation for that area is 8.5%, and you need a transition of 47 meters. Now, what is transition? Transition length also can be also known as spiral length. So normally when you have a tangent, you fit in a curve, something between your curve. This is something between a tangent and curve. The length is called spiral. So this spiral length is important. Okay. So and then this is for horizontal. We'll shift to vertical. Normally vertical alignment is something you want to see a profile of the whole road. Now, how do you do this is when you for instance you're going uphill. Now first you go uphill, then you go downhill. You cannot have a sharp thing there. So you have to have a curve. The curve on top on a uphill and going up and going down is called a crest. Meanwhile, if it is going down and then it's going up, it's called a sag crest. So this is the standard, this is the minimum values to determine the sag and crest. Okay. So moving forward, then intersection, I think I will discuss this with you in RSC stage 3 later. Climbing, okay. Normally when you have a road which is more which has a high gradient, so you need to provide a climbing lane. Why? Because you have heavy vehicles. If you have a certain percentage of heavy vehicles, and normally when heavy vehicle going uphill compared to passenger car, they will have it will be harder for them. So the reduce in speed can affect the operation speed of the area, and can also affect the road safety of the road user. So now that's why we will normally provide climbing lane. Climbing lane, if you want to see a good example in Sarawak, you can see in Teluk Melano from the stretch from the Pan Borneo Highway from Teluk Melano to Sematang there are few climbing lanes provided. That is climbing lane. Overtaking lane is at the area where it's normally generally straight, or where you think that people can overtake. There is no much access. You provide overtaking lane for people for the road user to go faster. So this one is normally you can see from the road from Kuching to Serian there are few overtaking lanes there. And then the next, we are going to traffic signs, road marking, and furniture. Okay, this is the one of the standard that we refer is STD DRWS6. So now, from here you can see we will normally measure the length of all the road markings, the height of the road signs and things like that to make sure that it is compliant to our standards. So this is an example. At side we have mentioned, but normally what we do is at this stage 2, we will check in the drawing first whether everything is okay or not. Okay, but this is to give a better, clearer view. And then TMP and everything we'll discuss in RSA stage 3 and above. Okay, go to RSA stage 3. So we will double check because we will go through the thing again because all these things because whatever based on the RSA stage 2 decisional meeting, we will actually know what is the thing need to be changed. So we will go through check all the changes. So design, I think these two items we have covered. This will be then we'll go into horizontal vertical alignment like this now. Just now I showed you the standards. Now I give you an example. This is the alignment control plan as I told you just now. Normally, as I told you just now, there is a tangent, and then you have to feed in the spiral. So you see this is the tangent, then you have spiral to tangent and spiral to curve. This is spiral. This is the spiral here. Spiral, then curve. This is the curve, and then spiral to curve, then spiral to tangent. So these are the things. So normally what we do check is we'll check the radius, whether the radius is correct or not, based on the standard just now. Next, we see the LS, the length of spiral. Then after that, we see the super elevation is correct or not, the speed, based on the speed. Then the other thing we will check is the length of curve. Length of curve is normally, we use 3V requirement. According to ATJ 86, normally your curve length should be 3 times the speed of the road. So if the speed is 70, it should be 210, something like that. Okay. Next, that is horizontal. Now go to vertical. Vertical, this is an example. What we will see, this is the vertical VIP, vertical intersection point table. So you can see all the information here. This is the gradient going up, rapid, how much is going down. So normally, for any project, according to ATJ, you should not have a gradient less than 0.5%. Why? To ensure the water can flow. Some area, as I told you just now, when you have super elevated area, at one point you will have a tangent runoff where this area will be flat. When this area is flat, what will happen is water tend to be stagnant. So through the profile, that is through cross section. Now, via profile, if you don't have any 0%, that water will find its way out of the road. So water ponding will not happen, and you have a maximum gradient for based on each standard. So we have to check whether this the profile, I mean the designer has exceeded it or is still within it, and then we will check the K value which I showed you just now, and then we also check the super elevation down there, is it correct or not, the super elevation development, and also we will check from here we can also check the horizontal and vertical combination. Okay. So just now, then next will be intersection. Just now we spoke about intersection. This is an example of intersection drawing. So acceleration lane, deceleration lane, all of this you can see here. So this will be a deceleration lane from the main road here. You're going in. So you have to go slower, right? So this is the deceleration lane to go into the new road. And then here is the acceleration lane. From here, you're going out. So you can go fast. You need to go fast in order to catch up with the speed here. So this is acceleration lane taper. And then you can also see there are storage lanes and the sign the box what the road markings here. So the reason we have marked this is because this is not later based on latest standard. This no stopping box is the junction box is wrong because the new one is not like this, it's just an X there. So we need to check, and we also have to check we also have to check the queuing length and everything, and the storage lane and everything there. So this is an example of the intersection. So moving forward, I think this one we have discussed, and this one I showed you some example already. The TMP will go and look at it in stage 4, part 1. So this is the compliance. As I told you, RSA stage 3 compliance. We will check the compliance based on the decision of meeting the client. So with that, when the consultant resubmit, we will check this. So if it is everything okay, normally after that, the next stage will be construction stage. So this is stage 4, part 1. Next, we are going to stage 4, part 1, part 2. Okay, stage 4, part 1 to review the compliance with the MP requirement and verification audit for stage 3 compliance. Okay, now we will do another step to double check on whatever was decided in the decision meeting is complied or not. So that will be the verification audit, and we will audit the TMP submitted by the contractor. In stage 4, we will do verification of TMP on site and work completed. Okay. So now I'll show you one example. Okay, this is the example of the TMP. So the contractor will submit this TMP. This is a TCP drawing submitted by the contractor. So we can see how they are planning to manage their traffic, right? This is an example. And also In this TMP, the contractor will actually put in their work program, the stages of TNP, they will how they want to divert the traffic first, then how they want to move on. Normally, the TNP stages will be there'll be or two or three stages, and sometimes more depending on the severity of the work sequence. And then after that, also we will also see the ERT, emergency response team, make sure they have provided a proper flow chart, and also they have provided other important details. Normally, what are the barriers they're going to use there? Like they're going to use plastic barrier or concrete barrier. Normally, if you have an excavation more than 1 meter, you cannot use plastic barrier anymore. You have to use concrete barrier. Plastic barrier, if you want to use plastic barrier, you must actually fill water into the plastic barrier, and it must be interlocked. And a string delineator must be provided on top of it for proper. It can be seen at night. So and then the colors of the plastic barrier should be. I mean, they should alternate between red and white, as you can see at side. Normally at side, what we can see nowadays, people do provide that, and they normally alternate the red and white. It's not a problem, but they do not interlock it. That is where the problem starts. Similarly, if your excavation more than 1 meter, you will have to provide a concrete barrier. Concrete barrier normally is black and yellow. So you have to interlock that also and have the string delineator or things like that to warn people there is something there. And you have to have a spacing uh, between the through traffic and also the plastic barrier or the concrete barrier. So it is 0.6 and 1 meter respectively. Okay, so moving forward, this is another example, or as I was telling you just now. So this is the plastic barrier and everything. So you have to have a arrangement of the barriers and all the things we'll check. And we'll also see the speed reductions, and all these things must be in compliance with ATJ 2C85. So next will be stage 4 part 2. So stage 4 part 2 is normally done at site. This is some of the pictures we have taken from site. So if you can see this picture here, it is a concrete road. So we are checking the usable shoulder here, and you can see all these plastic barriers, what happened to them. They're not even interlocked and they have already fallen. So they did not fill into it. So this is one of the things we are looking at. And you can see I think most of the pictures I've shown is the problematic pictures. So you can see what are the things not to do lah. If you are working at construction and you're even a consultant, you know what to see, what to expect. Now, so this you can see what is happening. You should have a proper separation here. You have to put a barrier between the heavy machinery working and everything, which they did not do. So next, sorry. Okay, and you can see this is not the way you have to put in your look at it, they just put a barrier here, and these things should not be put on top of the road here. So they have to have a proper way of arranging this signage and everything, advanced warning signs and everything. So, but they do not do this. So this is an example of what not to do at site. Okay, moving forward. So stage 4 part 3. Stage 4 part 3, normally what we do is this is before the road is open to public. So we check the general grading, alignment, cross section. Okay, whatever the drawings we checked in RSA stage 3, because the process is throughout the project, right? So whatever we did whatever we checked on paper during the design stage, we have to be taking it on at site now, whether it is implemented accordingly correctly or not. So general alignment, whether we follow or not, and then the cross section, we have to see the cross section, the lane width and everything. Normally we measure the shoulder width and everything, and also the grade. I think I'll show you pictures of this so you can see it better. So you can check we have something called inclinometer. So we use that to check the super elevation, the what the crosswalks, and also the gradient and things like that. So, and then general roadway layout features. So, and then next we will check on the traffic signing example, which I showed you just now, where we measure the height of the sign and everything. And then road safety features like the guardrail, the height of the guardrail. Normally, the height of guardrail is 710 mm plus minus 20. So if it is within that, there is no problem. And also the spacing between the guardrail post to post, you need to check as well. Then drains and curb. And this thing, I think I'll go in detail after this. Okay, now this is the inclinometer I was telling you about. So if there's no inclinometer, this is also the way to check the levels and everything. So this, when we put the inclinometer, we can actually check the crosswall of this, the crosswall whether it's in compliant with the with the drawings or not. So this is an example. Next, roadway features. Okay, this is the roadway features. Now we are measuring the betul. This is the usable shoulder we are measuring, and then we also measure the after that we measure the carriageway width and everything. So this is where we do all this measurement. And then traffic sign and road markings. This is the traffic sign. We normally what we measure and everything. This is an example. So all of this we will measure to ensure that it is in compliant. The next one is road safety features. This is the guardrail, as I told you. The spacing between this post to this post. If the drawing says 2 meter, make sure it is 2 meter. If it is more, then you have to tell them that it's not red. You have to put it in your audit report. Similarly, the height of all these obstruction markers. And then this is the drain. I mean, how far is the drain from here? This is a photo of the picture. Next, this is the example of it. So we go to RSA stage 5 now. Okay, RSA stage 5 is conducted after the construction is completed. This is one of the things I check as a as-built of road condition, and then focus on signs, marking, because all the main part of the road has been already checked and verified. So now, focus on signs, marking, barriers, visibility, and identify any remaining traffic hazards which we haven't found it. It is very similar to stage 4 part 3, but it focuses on operation, how the traffic behave and the functionality mainly. So now, what we also check is normally we'll check the skid marks. Normally we check the skid marks on road so we can see is there, I mean, where suddenly if we can see where people actually put a sudden brakes, and if we know why, and then we can see why. We will study why people suddenly put brake here. What are the potential impact to the road after this? So those are the things we study. And then if we see any guardrail which has already been damaged, so we know, okay, this is the issue, why. And if sometimes is there any water aquaplaning after that, any water ponding on the road, things like that we can check. So this is one of the example. So traffic sign blocked by tree branches. I can see this, right? This happens all the time. And then the other thing also we've noticed sometimes after a project is done, suddenly the project maybe is done by a different authority, and a different and when to the beautification of the place goes into a different authority. Sometimes this thing doesn't they don't correspond well, so it creates more problem as well. Sometimes the foliage of the tree may affect the sight distance of the road user here. And then you can see here this picture. This is a picture. So we put this picture here because we have even worse pictures. We put it because you can still see the signage, vegetation covering the signage as no proper maintenance is made. So sometimes it's people who are supposed to do the maintenance, or even the contractor themselves, after the project is after the project they have hand over the project, but they still have the DLP. They have to do the maintenance. Some of them they tend to overlook this. And then this is another issue where people illegally cut the guardrail, and then they've created an access without installation of proper in terminal. Why is this a problem? For instance, you're going very fast and you accidentally turn left, and you can hit this thing, and this thing can be very, very dangerous because this is sharp. And based on your speed of your car, sometimes it can actually cut your car into two, and it's not good. It is very, very unsafe. So so you have to have an in-terminal here. In-terminal treatment is very important. So this is what happens. This is the problem, implication of vandalism or but improper illegal access created without proper installation of in-terminal one of it. So you have to actually install a proper in-terminal, and also you can see now you can see here this shielded. This guardrail is actually shielding this street lighting here. So if they cut it a bit further, this street lighting is no longer shielded. So because it's very close to the road, cars can just hit it and it can create another impact to the road user. Okay, now, so since we have just glanced through the entire process of road safety audit, stage 1 to stage 5, so um, I just want to show you an example of how audit summary looks like. This is how the audit summary looks like. So this is how we will normally comment. I have redacted the comments here because it's PNC. So this is the generic template. This is where we put our comments in. This is where the consultant or the contractor responses. And then after that, if we have any disagreement or in concurrence, we'll bring it to a decision meeting and we'll let the client to make the decision here. So we'll put in here and this will be minuted. So next, okay, the challenges in Sarawak is different because we have to know that Sarawak, the what earth is very, very different because it is very, very vast. The landscape is totally vast because you can see flat areas, we can see areas with peat, we can see real mountainous areas like if you go to SSLR area, Sabah Sarawak Ring Road area, it is real it's done at mountainous areas, and also projects under NRDA, Northern Region Development Authority under Rekoda. Those things or those projects there also in highlands, so those are very when you have highland projects, you have to sometimes you have issues in compliance of the vertical geometry. So, and also sometimes a horizontal as well, and the combination will be very, very problematic. So this is where the LVRR comes into a play to actually, because according to ATJ, it allows until 17% of gradient, but LVRR allows up to 23%. So, and then also you can see the design speed inconsistent. Sometimes you have to reduce the design speed at certain areas due to some constraint. Sometimes you have a big building or cemetery in between your roads. If you have an existing road and you're going to upgrade it because due to traffic, and suddenly you have to reduce the speed because you cannot get the lane width properly because of there is a cemetery which is overextended and things like that, so you cannot actually widen it properly. So what you do, you will have to create a traffic calming this thing by using the you have to reduce the speed and things like that. So those type of things, yeah, you have to take into consideration. So that is the design speed inconsistency. Then steep gradient. So you have frequently, if you have high gradient, you have to provide climbing lane. Then if you see the third picture down here, this is water ponding. When water ponding happens, when uh, when you have water more than certain amount of water on road, what it can do, it can, the tire have some pattern down there. So what happens is this water tend to stick in, go and fill up the thing, and your car can slide. So that's what we call aquaplaning. So the car will slide and it can, just slide out of the road and, create more problem. And then the next is mitigation adoption barriers. So sometimes you have the mitigations, there are a lot of mitigation issues we have. Sometimes you don't have the space for it. Like some projects, if you notice, if you go to Long Lama, the town, if you can see the road lighting and the telecommunication pole is located very, very close to the road. So normally you have to have a certain distance. You don't even have a place to put the barriers or to shield those things. So what do you do? The safe what the client decided is to ensure that it can be seen. When it can be seen by people, especially at night, what you can reduce the likelihood of these crashes happening. So they have put in these special stickers so it can be retro reflective, so people won't go and bang it lah. So example like that, and then some passive calming techniques like the landscape, planters. They tend to fail due to our one of it is our sometimes we tend to have flooding, and also it is not maintained. The main thing is about maintenance. Sometimes due to maintenance, these things tend to fail. So and then the next one is travel. Sometimes we put RRPM. RRPM is the stats we put on the road which blink up. Sometimes those things are also you can see today it is there, tomorrow it is not there. So those are the things which can happen at side there. And then rigid roadside elements such as as I told you the road lighting and what telecommunication poles and all these things, right? Those things need to be shielded so that it doesn't, when any crashes happen, it doesn't fall on the car and create more problem. So, and also the distance between the drains and everything, because if it is too close, people tend to, with one misstep, they can go into the drain, so they can end up inside the drain. So, you need to have a proper distance and all those things. Okay, if you see the first picture here, these are the very closely spaced junction, you see. So when cars can go in and come out at all this location, so what is the mitigation they have used here is they have included the transverse bar to reduce the speed here as a traffic calming device. So and also this is also a staggered junction. What we can do is normally you tend to put the staggered junction signs, and also maybe you put in a little bit more road starts and things like that. So the sometimes the location of junction, this happens, right? This closely spaced junction issue sometimes don't happen during the project. It happens after the project, maybe 2 years after the project. Also, this thing can happen because suddenly some person decide to open up another. Uh, they decide to build a house and they suddenly decide to have a new junctions and things like that. Sometimes it's illegal, sometimes it's legal. Sometimes they just cut off the guardrail and as example just now. So those are the issues can happen here. I think that's it from me. Thank you. Thank you very much. So I pass it back to Miss Angel.
Okay. Hey, I saw there are many questions coming from the audience. Let me read it out for you. So the first, okay, let's move on to Q&A session right away. The first question is coming from Nadia. So she asked, can you explain the requirements and warrants for climbing lanes versus overtaking lanes?
Okay. A climbing lane is basically a reason of having climbing lane is because of the gradient. It's more on a gradient, and that's for climbing lane. And overtaking lane is mostly for to ensure it's normally done on a relatively flatter area, but not necessarily that way. But it is to actually allow another car to go and overtake, and you create another lane to actually for overtaking. So that is another is a different thing altogether. Climbing lane is to ensure that the operation speed is not reduced. So according to ATD 86, there is a section on that saying that for climbing lane, you should not have more than 25 kph drop of speed, and also there are few other things there, but this is one of the things. So you have to provide the climbing lane. So in ATD also nowadays, they have also specified if you want to provide climbing lane for one side, You have to provide for both sides. And even if it is a single carriageway design, you have to put in a median, and you have to have both sides is considered as a. It should be designed as that climbing lane section should be designed as a dual carriageway. So that is another thing. But sometimes due to cost constraint and everything, people do not do that in locally. If you see, if you go to Teluk Melanus Matan, that area, the climbing lane you can only see 3 lanes, not 4. It's not compliant to ATJ, but due it is this decision was made to actually to based or due to the traffic volume and everything. And also the question just now from Nadia was what again? Sorry, yeah.
So
Uh,
she was
Overtaking lanes.
asking, yeah, overtaking lanes.
Okay, overtaking lane is basically due to the. Also, let's go back to the traffic. If the area's traffic is a bit more, and then you have to ensure that overtaking lane is allowed. So so you will provide another lane, but this is nothing to do with the reduction of operation speed, but this to expedite the operation. Yeah.
Okay.
Next.
Okay, next question. It's coming from Nadia as well. So she asks, could you please clarify the differences between the purpose and scope between RSA Stage 4, Part 1 audit and the additional TMP audit for work zone traffic management?
Okay, now RSA stage 4 part 1 is when they actually the contractor actually first submit to us the TMP, the traffic management plan, and we audit on their TMP. The TMP submitted, we will audit it and see how is their general management plan for the overall project. So that's where we see the ERT and all these things. Then next, we will see for the additional TMP audit, it is what we audit, we normally audit TMSR, Traffic Management and Safety Report. That is normally provided every quarterly. So normally what we do is we audit that, and we also for stage 4 part 1 is not necessarily we do a site audit depending on the situation. But stage 4, the in terms of TMP audit, we need to go to site and also verify things at site.
All right. The next question is coming from Abdul Ghaffar. So he said, hi Dr. Egi, great session. Just a quick question. When is RSA stage 5 carried out? After after 6 months of construction or different? Do stage 5 have phases? For example, after 1 year, 2 year, and so on.
Okay, normally, it's a good question. So it's what happens here is normally stage 5 is conducted after 3 to 6 months after the road is open to public. Normally, if it is an existing road, which is, some roads, right? Some road projects is goes on with live traffic on the road. So those things we can do it. Normally, we what we do is depending on the client's requirement. Sometimes we do it 3 months after the construction itself. Sometimes, for new roads, we will normally do it in 6 months. That's all we do. I think there is no additional things after that. So we it's only done at 6 months after the 3 to 6 months after the construction.
All right. So I'm taking one last question. This one is from Joe. Okay. So the question is, why are acceleration and deceleration lanes sometimes required and sometimes not? What are the criteria for determining whether AC or DC lanes are required?
Okay. Um, Acceleration, deceleration lane. Okay. The main reason you normally require this is to ensure that there is, in terms of operation, because okay, main sometimes why it is sometimes there, sometimes not there. Okay, now let's answer the first question. Sometimes the road, okay, the speed of your road can be very very small. Your the road from to the difference of the speed between these two roads can be the difference can be only 10 kph or 20 kph. those reasons, and also depending on the site constraint. Sometimes you do not provide because you have multiple site constraints like utilities, you don't have land at that area, those type of things. And also sometimes also you have to look into situation. Okay, if you want to provide, I mean, there's multiple access on a road. So what is that access is serving? Sometimes if you notice, some accesses only serve one house. If you even in Penbonia Highway, if you notice, there are accesses only serving one house, one dwelling, or one. You can also there are. I mean, second trunk road. There are multiple roads only going into one kebun, one plantation. So those type of things doesn't and the your traffic count would not be enough. The traffic is not much, very minimal. It's very low volume because you see if there is one house, how many times you go in and go out from your house? Not many times, right? Compared to if you want if that particular express is going into a taman, into a housing area, there will be many people there. The population will be high. So and also there will be many people there. One, secondly is your what many people, and then also you can have the numbers of vehicles also will be a lot, so there'll be a lot of people going in and out, so this can actually affect the operation speed, the actual operation speed of of the main road there. So that's the reason we normally provide the acceleration deceleration lane. So it's basically, oh, okay, thank you. It's basically based on the traffic, one of the reasons. Secondly, about the land availability. Third is also about the difference of speed of the main road and the connecting road. And then finally, we can also say about the cost and the functionality of that particular road lah. These are the reasons. Sometimes we have, sometimes we don't, and sometimes you think it doesn't have, but maybe they have a future planning when that area is developed, they will have it. Yeah, thank
Okay,
you.
right. Thanks, Iggy. Uh, So, in wrapping up the session, we have been treated to a session that was informative, okay, in the world of road safety audits practices in Sarawak. Uh, a special thank you to our speaker for sharing his valuable insights. Eggy, do you have any final remarks to the audience today?
Um, Final remarks is normally road safety audit is now is being slowly being practiced in Sarawak. I mean not only in Sarawak, in whole Malaysia. So I mean if there is any questions on road safety audit, you can always contact me. I believe there are other questions there, but we didn't have the time to go through it, right? You can always contact us directly. We in Brand here, we can actually help to answer these questions. Thank you.
All right. Additionally, we have a moment ahead as we present a certificate of appreciation to Egi for his contribution to as today's webinar guest speaker. Okay, so Egi, this is your e-certificate. I will definitely email it to you.
Thank you.
All right. Now.